Okay, today we are doing function operations. This is the addition, subtraction, multiplication, and division of multiple functions together. Some of them evaluated at specific values.
You had me in the first half and then lost me when you did all together.
So let's go ahead and start with an example. On this example, I have two functions. The first one is f of n, which is equal to 4n as a function. And then my g function, which is equal to 2n minus 5. And it's just the variable that's present in here. And then I would like to find f plus g with n left inside. So this literally means I'm taking function f and adding to it function g and then simplifying, leaving my variable there. So this becomes 4n, which is my f function, plus my g function, 2n minus 5. I get rid of the parentheses, which allows me to go ahead and start combining my terms. 4n and 2n become 6n, and then minus 5. So f plus g of n is equal to 6n minus 5.
So instead of plugging in numbers, you just combine it.
For right now, yes.
For right now.
Questions, concerns, or issues on that one? Yes, Grant. Yes. Correct. Yep. Yes. When you write your answers, I do need to see what operation we were performing and then what it was equal to. So this is how I want all of your answers written. Of course, the plus will change depending on what operation we're dealing with. Let's go ahead and do a second one. So on this one, I still have two functions. The first one is g of n, and that is equal to negative n squared minus 5n. Then I have f of n, which is equal to n minus 4. And I would like to find g plus f of n. So this time I'm doing addition, but I'm doing it in the opposite order. The order does matter when we're doing these operations. So we always move left to right. My first function here is g. My second function that I'm adding to it is f. So this means that g plus f of n is equal to negative n squared minus 5n plus n minus 4. If there were any subtraction here, I would distribute it. There's not, so I can drop the parentheses. And I have negative n squared minus 5n plus n minus 4. I put together like terms. So here I have a negative 5n and a positive 1n. What does that combine to equal? So this becomes negative n squared minus 4n minus 4. Nothing else can be put together. So that is our simplified addition function. So then I just go ahead and write it out formally. And I'm done. So g plus f of n is equal to negative n squared minus 4n minus 4. I know. How difficult do we think this is so far?
Addition.
Is it easy like I promised?
The addition part.
A bit.
So far.
Let's do another one.
Right, isn't it?
So we're going to be like, oh, it's funny. We go to Albuquerque, go right instead of left.
Okay, so this time I have two functions, f of x and g of x. So here I've changed my variable from n to x. That's okay. It doesn't have to be one specific letter. A variable can be any letter representing an unknown. This time, instead of addition, I would like to do subtraction, and I would like to do f minus g of x. I'm still going to set it up the same way that I did before. My f function comes first, and then minus, because it's subtraction, my g function in parentheses. So this is why we use the parentheses. Because now instead of adding, I'm subtracting, which means I need to distribute this negative to everything inside my second parentheses. So when I take the parentheses away, this becomes negative x squared minus 3 plus x minus 2x plus 5. And then just like before, I combine like terms and simplify it down. So nothing combines with my x squared, so that's going to stay. I have a positive x and a negative 2x, which means 1 minus 2 equals negative 1. So I have a negative x here. And then negative 3 plus 5 is a positive 2. So my subtraction, f minus g of x, is equal to negative x squared minus x plus 2. If you want to put a 1 in front of that x, you're more than welcome to. It can be negative or minus 1x plus 2 if that helps you. How do we feel about that? Anybody confused by anything that we did on this problem? If there's a subtraction, you have to distribute it to the entire second function. Exactly what it says, yeah. Which is why order is important, because if I did g minus f, I would get the wrong answer. Okay, so we must follow the order that the problem is written in. Let's do another one. This time I have the function h and the function g. And on your own, I would like for you to find h minus g of x. So on your own, please solve this problem. We'll do it together at the end. I gotta fix my attendance real quick. Pfeiffer, tell me how I'm going to set this up. Okay, then what? Now what? So when I distribute the negative, I should get 3x plus 3 minus x squared plus 4. Is there anything I can combine here? Yes, what is it? The 3 and the 4. I'm also going to reorder this so it actually looks like a quadratic with my x squared first. So this becomes negative x squared plus 3x plus 7 because 3 plus 4 is 7. And then that is what h minus g of x is equal to. How do we feel about that? How many of you got that correct? You could have had it in a different order. That's okay. Just as long as the numbers that you got were right. Anybody have any major issues with that one? Okay, let's do another one. My first function f is n minus 5. My second function g is n squared minus 2. And I would like to find f times g of n. It is important to note that when I have multiplication, it is a closed dot, not an open dot. There's a very big difference between the two of them. So make sure when you're writing it, it is a closed, solid, completely filled in circle. Okay? Yes. And it is exactly how it sounds. I'm going to take my f function and I'm going to multiply it by my g function, which means I'm probably going to have to FOIL. So my f function is n minus 5. My g function is n squared minus 2. We're going to go ahead and FOIL this. I'm going to color code for the first one so you see what's happening. For FOILing, we multiply our first terms together first. So what's n times n squared? N cubed. Then I go ahead and do n times a negative 2, and that's a negative 2n. Then we have negative 5 times n squared to be a negative 5n squared. And then negative 5 times a negative 2 is a positive 10. From here, we go ahead and simplify. There's actually nothing that I can combine and put together. So I'm just going to reorder it from largest exponent down to smallest exponent. Yes, Pfeiffer. Wasn't that just an I squared?
Yeah, that was.
Okay. So this is, Pfeiffer tried to say that we could change n squared into a negative 1, but that only works for I squared because I is an imaginary number. So make sure you know those are separate. At least you were trying to remember though, I like that. So when I reorder this, I get n cubed minus 5n squared minus 2n plus 10. And that is what f times g is equal to. Questions, concerns, or issues on that one? No, we're good? Okay, I'm going to give you one to do on your own. Grant, I'm going to call on you for this one, so you better get it done. I believe you. Yeah.
So I was one piece.
Yeah, I'm not answering that yet. Because probably something that we're going to do is very similar to that, and it'll answer your question.
Well, no, I've got it to where I'm just confused on
Negative n3 n cubed minus n cubed. So that'd be negative 2 n cubed. It'd be negative 1 n cubed minus negative, or minus 1 n cubed. Negative 1 plus negative 1 is negative 2. Okay, Mr. Grant, talk me through this, please. Okay. Okay, then what? Okay, so what happens when I FOIL? What do I get when I FOIL? Just read me off what you had.
Negative 16n squared.
Then what?
4n and positive 8n. You get 12n. 2 positive 6.
Okay, is there anything I can put together?
Positive 8n and 12 negative 4n.
Is there anything else I can put together? Good, because then that is your final answer, negative 16 n squared minus 4n plus 6. Show of hands, who else got that answer? Is anybody confused by what we're doing so far? We have one more operation to go, and then we're going to start solving at specific values. It really isn't any harder than this, though. It's just one extra step. You'll see what I mean. Okay, next.
I don't like you. No.
Oh. Boy. And then I would like to find h divided by g of x. So now we've got division. The really cool thing about division is that you really just have to write the top function over the bottom function, and then that's it. So this one is going to be my h function over my g function, because that's how it's written in the problem. And then I just go ahead and write what those functions are. And then I'm done.
Wait, that's it?
That's it.
Yeah, but it gets fun when you add the answer.
That's all you gotta do.
That's all you had to do.
See, but Smile is throwing me a curveball. Oh, I'm not mad the answer for X.
Let's go ahead and do another one because I think you guys are ready, and then we are almost done with the notes.
Oh, is
Yes.
that the truck?
Yeah, of course, honey. Sorry. Is that enough?
Yes.
Okay. While she's writing, here's the one you're going to do on your own. And then I would like for you to find f over g. You're funny. Are you done, Ariana? Okay. So this is the one you were doing on your own.
Question about possible future conferences. I haven't scrolled through all the homework, so I don't know if it's on there. But with the division, if you have the variable input, you stop. You just leave it as is, or would you reduce it?
I think I'm kind of confused about your answer.
Right. Say if x right now was 2, you would do 2 square root 4 plus 2, 6, 2x minus 4, 4 minus 4, and you would get 0 for that.
Madison, talk me through this one.
Take green, for example.
How do you know you had to put the f over the g? Shh. Right, so we looked right at how it was written. We have to follow that, right? Perfect. So we put my f function. What's my f function here?
X squared plus x.
Good. And then that goes over my g function. And what's my g function?
2x.
Is there anything else I needed to do? Nope, we're done. How's that feel?
Great.
Awesome. Let's switch it up a little bit now.
Oh no.
Now it's not.
So now, instead of leaving variables in our answer, we're going to start inputting numbers. The only change this makes to what we've been doing is that we have, after we get here, the extra step of plugging in a number and solving it. That's the only change. So we're going to do one of each operation, and then we're going to be done. Because I don't think you need a ton of examples here. But we're doing it this way. Okay, so I have g of n as my first function, and that is equal to negative 4n plus 5. And we have h of n, which is equal to n minus 3. I'm actually going to show you 2 ways of solving these problems. I will leave it up to you which one you choose to do. Okay, so I'm going to move this to the center, and I'm going to split my screen down so that we can look at both ways that you can solve this problem. The first way, I'm going to do what we've been doing. So I'm going to do g plus h as it is right now. I'm going to simplify it, and then I'm going to plug negative 7 in and be done. Okay, so if I'm doing that way, I'm going to do that over here. So I'm going to do g plus h of n first. When I do, I'm going to have negative 4n plus 5 plus my h function n minus 3. I'm going to simplify. I can put negative 4n and n together to get negative 3n. 5 minus 3 then is positive 2. So that simplifies to negative 3n plus 2. Do we all see how that happened? The extra step here is that I now take negative 7, I plug it in for n, and I solve. So this becomes negative 3 times a negative 7 plus 2. Negative 3 and negative 7 combine to get a positive 21. Plus 2 equals 23. So we got 23 on that side. Yes, you're still going to have to write the g plus h of negative 7 equals that. Yeah, the only difference. Okay, so I bet a lot of you really, really like that way. I'm going to show you an alternate way that's also going to work. It is entirely your choice which way you choose to do this. So I have the g plus h of negative 7, right? We know that's the problem that we were solving. This is the same as g solved at negative 7 plus h solved at negative 7. So I can find g with negative 7 plugged into it, get an answer, and then find h with negative 7 plugged into it, get an answer, and add my answers together. So if I were doing that, g of negative 7 would be my g function with negative 7 plugged into it. When I did that, negative 4 times negative 7 is positive 28, plus 5 is positive 33. I would do the same thing for h of negative 7. My h function is n minus 3, so that's negative 7 minus 3, which equals negative 10. And then I do add my answers together, which becomes 33 plus negative 10, which is the same as 33 minus 10, which comes out to be 23. It's the exact same thing, just the steps done in a different order. It is your choice which one you choose to use. I don't care, because they both work out the same if all of your math is correct. I actually prefer this way, but it is entirely your choice. Okay? So from here forward, I'm going to do it this way, because this is also a way that always works. You are free to do it however you want to. So that was an addition example. Now we're going to go ahead and do a subtraction example. So on this next one, I have two functions, f and g. My f function is negative 2n squared plus 4. My g function is 3n plus 1. And I would like to find f minus g of 4. So I'm going to do f minus g with the n in it first, simplify it, and then plug in the 4. You're free to do it however you want to. So this means I have negative 2n squared plus 4 minus 3n plus 1. I distribute that negative, and I get negative 2n squared plus 4 minus 3n minus 1. I go ahead and combine like terms, and I get negative 2n squared minus 3n plus 3. And then I'm going to go ahead and plug 4 in for n. When I do, I get negative 2 times 4 squared minus 3 times 4 plus 3. I just plugged 4 in for n. 4 squared is 16 times negative 2 is negative 32. Negative 3 times 4 is negative 12. And then plus 3. I add that together, I get negative 44. Plus 3 is negative 41. I will give you guys a minute to catch up and check your work with mine. Everything. Both ways will work for everything. Yep. Yep. Both ways that I showed you will work for every single problem. That's why I leave it up to you which way you'd like to do it. Some people like one way better than the other way, and that's 100% okay with me. We have 2 more operations, and then we are done. I'll give you guys another minute to finish writing this, and then I will write the next example. Okay, so the next one we're going to do is multiplication. So in this one, I have 2 functions, h and g. So my h function is 3x minus 2. My g function is 2x. And I would like to find h times g solved at 6. So h times g of 6. Again, I'm going to solve it the way that we multiply the functions together the way they are, simplify it, and then plug the 6 in. So this becomes 3x minus 2 times 2x. I don't have to FOIL here, but I do have to distribute the 2x into both of those terms. When I do, I get 6x squared minus 4x. And then I go ahead and plug 6 in. When I plug 6 in, I get 6 times 36 because 6 squared is 36, minus 4 times 6, which is 24. I go ahead and I do 6 times 36, and I think I get 216. I think it's 216. Yeah, it should be. Minus 24. Of course, you can go ahead and use your calculator, and you get 192. And then that's your final answer. Yes, exact same thing. Before I put the number in, yes. Any questions on this one? I will give you guys a minute to finish it, and then we have one more example. And then I'm just going to write a couple of things out formally for you, and then we're finished. And you should have plenty of homework time. Okay, not plenty, but some. Okay, last example. I know you're all so excited. This time I have 2 functions, f and g. And I'm going to use the variable t. Make sure you're very careful about writing your t's versus your pluses. And I would like to do f divided by g solved at -9. This works exactly how it did before. My f function goes on top, so I have t squared plus 2 on top. And then I have 4t plus 2 on the bottom, which is my g function. Then I go ahead and I plug in -9 for t. When I do, I get -9 squared plus 2 over 4 times -9 plus 2. -9 squared becomes 81 plus 2 over 4 times -9 is -36 plus 2. 81 plus 2 is 83.
Wait, don't you mean plus? Oh wait, I wrote down plus 9 back.
And then -36 plus 2 is -34. So I end up with 83 over a -34. Of course, if we can simplify those, we should, but those will not simplify. So that is our final answer. We're going to write one more set of things in our notes, but it's not an example. It'll take us literally less than a minute. And this is just beneficial because not all notation is written the exact same way every single time. So I'm going to show you both ways that each of these operations can be represented because it is both ways on your homework. So this next section, I'm just going to title notation so you can see exactly what I mean. So the first one, if I'm adding two functions together, so if I have f plus g in parentheses and then an x in the second parentheses, that is the same as f of x plus g of x. So both of these mean the exact same thing and they can be written both ways. The same thing for subtraction. So if I have f minus g of x, that is the same as f of x minus g of x. Multiplication and division also work the same way. If I have f times g of x, that is the same as f of x times g of x. And then f divided by g of x is the same as f of x over g of x. So these are just the different ways that each of these operations can be written. They mean the exact same thing. I just don't want you to get confused on the homework. So once you write this, it is homework time. Of course, let me know if you have any questions. This is due tomorrow. Hold on, Brandon.